Okay. First, we gotta see what is this sloth. It's a sloth. Hopefully, you are like strong at the sloth. I guess. Alright, no way. We are here. Last time we do. What did we do last time? We move stuff up. Okay. Okay. So last time we look at this. And we look at this next. What's they doing here? Team. the custom tool to measure performance. Uh, Performance of system is a different scenario. We have chaos config. Metrics. Discovery service. Eureka. Very cool pictures. CI/CD. They migrate this blog post somewhere. Okay. Okay, so nothing informational that we care about. Just some tooling. Mm. Mm. Split data. Okay. Okay, cool. Yes. What about part two? Wait, what? Let's read about this tomorrow, maybe. Okay, next one this tool for viewing data store, many data storage system. Netflix. Suara. Okay. Hmm. Okay. Web demo environment running Docker containers. the last link we can find out about Cassandra. Data pipeline. They used to block in Medium. They still do. So basically Cassandra and Elasticsearch Kafka and so basically they're just queuing a lot of stuff out of Cassandra and do async flow data processor. Iceberg asset third party API. Okay. They do really like Cassandra as the main database. Bucket by access type. Asset by asset type. is broker. We are Kapsa. Okay, so error. Data is pushed to add meta queue. Okay, so they build data pipeline for some different analytics had to share with production. Okay, so we read through all the link related to Cassandra at Netflix. Seems like they heavily use it for viewing history, all that stuff. They also make a lot of tools and supporting analytics backup. Scaling is great. Riot 2 for load test. Enable Chaos Monkey to test in production. Pretty solid. Next we're gonna look at videos. Right. Let's look at videos. Okay, let's watch this. And pause the music a little bit.
Had this in-person meetup in the Bay Area, and I'm so glad to host you here at Netflix. This is an opportunity for all of us in the Cassandra ecosystem. All right, welcome everybody to Apache Cassandra Bay Area meetup. This is it's been a long time since we had this in-person meetup in the Bay Area, and I'm so glad to host you here at Netflix. This is an opportunity for all of us in the Cassandra ecosystem to reconnect and discuss all the advancements that are happening in the Apache Cassandra and how Apache Cassandra is solving the cutting edge technologies and addressing Gen AI, vector search capabilities. So it's amazing times to be in the community, and I'm glad we have this opportunity to, reconnect and discuss all the challenges ahead of us. Um, Really quick, few logistical things before we dive into this evening. You all know where the kitchen is, so if you need some food and drinks, building D kitchen area, and the restrooms are towards your left when you're walking to the kitchen. Um, for about 90 minutes, we will have amazing talks lined up from folks from Netflix, Uber, DataStax, and Apple. And after the presentations, after these talks, we still have 1 more hour, and we have dinner, food, and drinks arranged in the same area. So do stay back, connect, use this opportunity to talk to other community members and hear about all the amazing things that you're doing. Netflix also has 2 innovations put it as a posters on there, so we can use that as an opportunity for you to learn about what kind of distributed data access innovations that this team is doing. So now let's get into the interesting part. So we're gonna start with from folks from Netflix. Vidya and Raj, our amazing, stunning colleagues, talk about how Netflix handles Cassandra tombstones at scale and how SLO-based retrieval work at Netflix. After that, Jaydeep from Uber, Chris from Netflix will talk about incremental repair scheduling in Cassandra. So if you're operating Cassandra, this is a talk that you absolutely don't want to miss. And then followed by that, we have Dinesh, Apache Cassandra, PMC and chair. We'll talk about how massive deployments like Apple is handling the petabytes of data without basically using the passwords in a Cassandra 5. So I don't know. I'm really looking forward to how he's achieving that innovation. And lastly, we'll wrap with our world-renowned speaker, Patrick McFadden, our own. We'll talk about how GenAI and vector search are being addressed in Cassandra 5, and how Cassandra 5 can really help you for the next generation GenAI and RAG and vector search systems that you're going to build.
Move on already.
With that,
on,
so these are the faces. If you want to say hi after the meetup, please do network with them. And of course, I cannot end my talk without talking about my sales pitch. Yes, this team is hiring. We have roles open in several job functions, all the way from engineering manager to L4, L5 engineers. If you are interested, we are happy to chat. Talk to any engineer who doesn't have a badge. So those are the Netflix engineers. So learn more about, is it just a sales pitch, or is it really cutting edge technologies that we are solving? So my engineers are the best to talk about it. And if you talk to me, it's just a sales pitch. But without further ado, Vidya and Raj, take it away. Thank you.
Thanks, Vinay. That was a great introduction. Hi, I'm Vidya Arvind.
Hi, I'm Raj.
Today, we are going to talk about how Netflix optimizes use of Cassandra at massive scale. When we say massive scale, we want to talk about one quote that comes to mind. We can solve any problem by introducing an extra level of interaction. It's a very famous David Wheeler quote, and we want to start with that. We did introduce a level of interaction through abstraction, and before accessing the data stores, you're hitting an abstraction, and abstraction is passing or connecting to your data stores. And we started abstraction at early 2020. We started with a few production use cases. You can think of shards as apps that are connecting to databases. And with V1 API, very simple APIs, puts, deletes, and gets. And in 2009, we productionalized the first use case. That year, we onboarded 20 of them. In 2021, we had we grew to double. Right, when we grew to double, engineer of 3 couldn't handle how many provisioning requests we had to do. So we
Oh,
built
this is when they
automation
still
of
use
shards and
InfoDB.
namespaces and rewrote our control plane already. Within a year, we had to rewrite our control plane. In 2022, already we were growing. We wanted much more robust APIs. We were doing V2 API, high-level client, which could signal back and forth the intent. And we did chunking and scans. You can see the posters there and talk to our engineers about these posters. And in 2023, we did our biggest thrift migration. We moved from Cassandra 2.0 to 3 and now in 4. But we moved a lot of
Cassandra
use
4 now.
cases, around 250 apps. But the number of shards we created is 98. In 2024, we are innovating through business initiatives and adding new features like leasing and other features. Totally, we have 391 shards and around 3,500 plus use cases. Every use case is different, and you'll hear about that. With abstractions, direct access is gone. Most of the direct access doesn't happen now. Everything goes through abstractions, and 83% of them we have covered through abstractions right now, and only 16% is left, and we are planning to cover that. Our largest use case is 8 million QPS is what we are dealing with in abstractions. Among them, our biggest Cassandra cluster is operating at 1.8 million RPS and 4.9 million
per second.
WPS.
WPS is right per second.
That's our biggest. Key value is one of the abstractions that we have. And in key value abstractions, we do use cases like graph, trees, queues, entity service. We have features like chunking, near cache scans, deduping caching. We cater to needs of feature stores, events, frequency capping, recommendations, rating, you name few Protos, JSON, and some of the formats we deal with. Why abstractions? When you think about abstractions, you want a uniform interface, you want best practices to be applied, you want common patterns to be taken and done in abstractions. We want users to focus on their business problems, not worry about what database we are using underneath, right? We can decouple databases through abstractions and do seamless transition from one database to another, or go do migrations through abstractions. I want to talk high level about what key value abstraction is. Key value abstraction, you can think about it as a hash map of ID and a sorted map of bytes, which is one is a key and one is a value. We also store a little bit of metadata about the value, like what is a chunk? Does it chunk? If it chunks, does it compress? Things like that. Life cycle of data as well. Some of the key APIs we support are puts, gets, delete items, scan, and mutate items. Can abstraction transform chaos into clarity? That's gist of the question, and that's where we wanted to go with this presentation. One of the chaos that we see in Cassandra often is tombstones, and we wanted to tackle that today in the presentation. Tombstones are special markers, as you all know. When you delete the data, you create a tombstone in the system. And whenever GC grace period is done, you kind of go delete the tombstones. Specifically, when you look at the data, here I'm representing account data. Accounts and profiles, and profile information is what is represented here. When you delete through a partition, you are really deleting or adding just one tombstone. When you delete a range of keys, it's one tombstone marker. But when you want to delete a list of items, you're really creating a bunch of tombstones per key. When you go to get the data for partition level data, which is for account one, match all the information that is there. You're reading through the tombstones, you're filtering all the data out, and you only returning back the live data. But when you're doing a range, similar thing happens. You go to the key, and after the key, you read the whole range. And when you finish reading, you filter the tombstones out, and any data that is deleted data, you filter it out and return the value.
Okay.
Key match keys are much more easier. You're not reading a lot of tombstones. You're only targeting those keys and related tombstones. I wanted to point out one more API, which is the scan API. In most of the cases, or a lot of cases, we want to read the whole table. When you want to read the whole table, you go to the whole ring and start reading the token ranges for that particular table, and you want to scan the whole table. And you can think of each token range as a queue, and you're going through the queue and reading the whole data. If you display it linearly, you will see it here. You can see the posters about scan in our display. You can talk to the engineer about it. Scan, when you say match all, you're going through the whole table, reading the whole table, including tombstones, and you're trying to eliminate all the data and only read the live data, right? What happens when you're reading this much of tombstones, and especially when you have a lot of tombstones, you have increased latency, query timeouts, increased CPU utilization, high disk IO, repair performances are high. It affects your repair performance, and really what you see is like sometimes tombstone overwhelming issue. You're only returning 70 rows back to the user, but you read 16K plus tombstones, and it increases your CPU. Your CPU looks everywhere like in 100% mark, and you're under provisioned. We can do some operational stuff like force compaction. You can delete the partition and then compact. You can do bunch of these operational stuff, and immediately you see your system coming to a normal state. That being said, how can we optimize this via abstraction is the question. All of these problems exist in Cassandra. How are we dealing with key value abstraction? Raj is going to continue talking about that.
Thanks, Vidya.
Yeah.
So I'll walk you through some scenarios that will show how certain queries of ours get impacted with tombstones, and then what are the solutions we have implemented to mitigate these problems, right? So let's start with how a get items query with a match all predicate works in absence of tombstones. So the client also provides a page size, which basically is how many bytes they want to restrict per page of data that they are retrieving. So when the key value service gets this request, it makes a query to Cassandra with a limit by number of rows, and it tries to fill a page. And if the page can have more bytes fit into it, it will make additional queries to Cassandra and tries to fill up the page. And once the page is full, it will respond back with a retrieved items and a page token. And all this while staying within the SLO. Now, let's imagine what would happen the same case when tombstones are present, right? So there could be some additional latency in retrieving the data from Cassandra, and overall the accumulated latency can exceed the SLO that is promised, and ultimately the client could time out. So if we have to see that scenario, the initial query from Cassandra could return some data, but the query due to processing the tombstones could be a little latent. And to fill up the page, KV will make additional queries, and those queries could also be latent. And ultimately, this accumulated latency could be larger than the SLO promised, and the client would time out. So we potentially have failed the query, right? Like the client did not make any progress. And to mitigate this, we have introduced something called as limit by SLO. So the key value, instead of waiting for the page to be completely filled, it will detect that, okay, do I have some data to return? And if it sees that, okay, it's going to exceed the SLO by 80%, then it will return early with a page token. This ensures that the client is still able to make gradual progress on the query without completely failing the request. So if you look at the previous scenario where Cassandra was retrieving some data and it was latent, in this case, key value will observe that, okay, the accumulated latency is almost greater than 80% of the SLO, and it will just return the data with whatever retrieved
So
results
they
it has
cap
with a page token. And this does not solve all the tombstone
return
related issues,
by limit.
especially let's see if there are large number of tombstones.
Okay, so they cap the data return to the caller if the latency is approaching 80% of the threshold. Okay.
Initial query itself to Cassandra could be very latent, and the KV will not have any data to respond back. So it cannot just return an empty results with the page token, because the subsequent query also will be starting from scratch, and it will not make any progress. So there will be deadlock. So to work around this issue, we have introduced something called as, okay, 1 second, tombstone spreading. So what does tombstone spreading do? Here, instead of issuing, when KV gets a delete request, instead of doing a delete to the Cassandra, it writes an item with a TTL and marks that item as expired. The TTL is chosen from a range randomly, and this is to ensure that when these items actually get deleted on Cassandra, there is no clustering of tombstones. And when KV retrieves these items from Cassandra, it does filtering. So you could imagine this as a KV layer of tombstones, additional tombstones that KV is managing. I'll highlight like what is the specific difference between the KV layer tombstones and Cassandra layer tombstones. So in this scenario, if we take a look, there are tombstones, instead of the Cassandra tombstones, we have items that are marked with TTL and marked as expired. So when KV retrieves these items from Cassandra, instead of Cassandra timing out, it will just return these items back to KV, and KV would be filtering out these items. And now KV can respond back with even an empty results with a page token, because the subsequent query, when it comes to key value service, it's able to paginate by resuming from where it has stopped before. So the main difference between the KV layer tombstones and the Cassandra layer tombstone is that the KV layer tombstone is able to be.
So basically in the KV cast layer, they added metadata when the item expire to filter out. Is that what it is?
Like we can paginate over the KV level tombstones, whereas on the Cassandra layer, you would pretty much get a exception saying you have scanned X number of tombstones and the query is aborted. So that's the key difference between the tombstones that we manage. And eventually the goal is that the query is able to make gradual progress without actually failing. So this solution ensures that we are making gradual progress, but it does come with trade-offs, such as there is an increased end-to-end latency that needs to process the overall query. And also there is an increased amount of storage utilization because the retention is higher than what is expected. But the system overall operates at a degraded performance, but still is not failing completely, which is acceptable in most of our use cases. And even then, this does require some kind of a balancing, like what would the right TTL be, what is the range of TTL that you should be choosing. And this depends on the compaction interval, the repairs, and then.
Do you not just set a TTL shorter so it's expire in Cassandra faster? I don't know.
The GC gray seconds. And then some of the enhancements in Cassandra that would enable KV to offload this operations to Cassandra would be Cassandra supporting limit by SLO. Like then we might be able to retrieve the data from Cassandra itself within the SLO, then limit by bytes. So we have seen KV making multiple round trips to Cassandra to fill up a page. But instead, if limit by bytes existed, we could potentially avoid those multiple round trips. And then the other one was the pagination of tombstones. So basically, even when there are large number of tombstones being scanned on the Cassandra side, instead of filling the query, if we get the response back and then an ability to paginate for the subsequent queries exactly from where we have stopped, not redoing the work, that would also enable
Mm,
us to make progress. And then incremental repairs, which actually enable us to purge
magic.
tombstones in 30 minutes.
Okay.
So that would be great. And with that,
Don't know.
I'd like to thank everyone and hand over to Chris, who is going to talk about incremental repairs.
Oh, that's what I need to know. Hold on. Netflix incremental repair. I really don't know, but let's take a look at some other videos. So confused. Sure.
Hello, everyone. Today we're gonna talk about all the testing and operation for Cassandra. So the title is Ensuring Cassandra Operational Excellence at Netflix. My name is Chung. My name is Josh. We have a brief introduction to ourselves. I'm a software engineer at Netflix for about 3.5 years. But I've been working with database work for like almost 10 years.
Mm.
I'm Josh. I
Is there a way to
interned
get a
on the
slide?
Cassandra team at Netflix last summer, finished my college up, and recently joined in February. So I rounded up, but approximately been at Netflix for a year.
Yeah, so this is agenda. So before we jump into the technical details, let me just give a brief introduction to the team, ourselves, and also give a brief introduction to the
We zoom in on
Cassandra
this
and Netflix.
slide.
So we are part of the online data stores team. So online data stores is pretty much like all the transactional, non-transactional data storage team. For Netflix, we operate a few different data stores, like Cassandra is one of the major one. And we also operate on like Cache, Vcache, Dynamite, which is like a radius-based, Elasticsearch, Zookeeper, and also.
Maybe we need to find different video because we need to see the slide. Netflix, Cassandra. Let's see. No, not a movie. Okay, let's do the Prime Agent one. I don't know. Hold on.
So yeah, you took the leap into Netflix. So what was that like?
It was, this is one of those things where when you talk about it, people love to trivialize this because it's like, oh, you're taking a leap of faith by going into a FANG company in like 2013. Sounds super risky. My wife was 36 weeks pregnant. We had to travel to a place where we knew not a soul. We were about to have our first kid. We didn't even have a doctor. If you don't know, having a baby does like you kind of want a relationship with a doctor. There's like a whole thing that goes on there. So it was a really hard and great experience. So I went to a job in which their culture deck. So during this time, this is where Netflix still had like kind of that old Generation X feel to it. Their culture deck was hire fast, fire fast. It was very in your face about like, hey, this is how we operate. You don't meet the standards, we kick you out. So it's like, I'm leaving a place where it's more secure to go to a place I don't know anybody, to a job that's bold in its claims about firing everybody, with a wife that's just about to have a baby. And so it's like, and I'm from Montana, and you're born every.
Wait, does Netflix get toxic like that? Threaten to fire everyone? What are you? What?
Montanans born with a natural dislike of California. So there's like all these things kind of flowing into it
Mhm.
where it's just going to be like, wow, this is a very intense experience. And it was hard for sure. Like it wasn't just some easy, simple experience that we were just like, oh, well, I work now at Fang. We had to kind of work through that. Having a kid was very difficult. Our first kid was very difficult. Not having any family around to ever help you. Like, it took a much larger toll on my wife than me for sure.
What was the technical learning curve for you? You showed up in your plaid pants, like
Yeah.
dressed up.
Yeah.
And what was it? What did you have to learn about the stack? Because Netflix, I imagine, is this incredible infrastructure that has to deliver just a huge amount of data. I'm just blown away by Netflix, but also like YouTube. These companies that have to deliver, like serve a huge amount of like bits.
You know what? It's interesting. Be interesting. It's like YouTube have a blog about the engineering. Do they? Maybe we'll find out tomorrow.
Netflix has it easiest out of all the companies Netflix buy, even though you could say maybe we beat YouTube in view hours. I'm not sure if we do, but let's just pretend Netflix has 5x more view hours than YouTube. Whatever it is, Netflix has a fundamentally easier problem than all other companies. And let's get back to that. I'm going to first tell you
All
about
right.
the stack, but
All
I'll
right,
tell you
the
why it has a fundamentally easier problem.
All right.
So when I first got there, they gave me my PlayStation 3. My boss said, go learn some code. Come back to me in a couple days and tell me what you've learned. And then I'm going to start giving you bugs to fix.
Wait. PlayStation 3, what are you talking about?
Well, I was on the TV team. I had to go plug in a PlayStation and start launching programs onto the PlayStation 3 and figure out how to work Netflix on a television device.
Oh, so like you have different kinds of devices. Why PlayStation 3? Is other different?
It's just 2013. That's
Any
what you
devices
had.
that plug into the TV. Okay, cool.
Yeah, not as many TVs had Netflix, let alone what they called their Darwin app, which is their new application.
Okay.
So if you bought a Vizio earlier that year, you'd get their older one there. It's called Plus UI. You get their older version. And so not many had the newer version. We no longer supported Plus, or we never actively developed on Plus. We only did stuff on Darwin. And so I had to learn that whole stack. The back end or the middle end, the middle layer between the actual back end and the front end was written in Groovy. And as I went around, Groovy is, if you're not familiar with Jenkins, then you've probably never interacted with Groovy. But Groovy is a JVM language. It's a very interesting language. But here's how it got started at Netflix.
Oh, it's Apache. Apache Groovy is a powerful object-oriented programming language that runs on the Java Virtual Machine, released in 2007. It has evolved to become a versatile language that combines both static and dynamic typing capabilities.
All right, so the AI is kind of lying to you. Groovy is not a powerful, great language. That statement makes it seem way cooler than it actually is.
Mhm.
You will meet 1 out of 100 people that have touched Groovy that said, oh yeah, Groovy's great.
Yeah.
The other 99 will be like, heavens forbid you ever have to touch that language.
Yeah.
So when I got there, nobody, not a single soul at Netflix, there's 40-some engineers, had any idea how Groovy pretty much worked. Somehow people just hacked together these scripts and put them all on there, and it worked. And this was before there was a Groovy RX port. We wrote our own version called WX. It was a nightmare. Observables, all these things. I remember one time they told me that, oh yeah, with RX, it's really easy. You just say what you need to do. It maps out and boom, 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 boom. Everything will run multi-thread and all that. And I was like, oh wow, really?
Is RX the reactive programming paradigm? Yep. Let's take a look at Netflix RX. Wait, Netflix doesn't use RX anymore. Okay, fine.
So all I did was go like observable.sleep1, because I just wanted to see it sleep and then do the next thing. And it turns out when a thread sleeps itself, no thread can wake it up. And I just turned off all of staging because I ran it like 10 times, like, oh, it's not responding. Oh, it's not responding. Oh, now it's not even coming back. Broke all of staging for everybody. So no developer could work for the rest of the afternoon because I locked up all the instances, because it turns out, no, it was in fact not multi-threaded. Every assumption we've been told is a lie. No one had any idea what they were doing. It was a wild time. And so I just simply naturally gravitated towards that because I'm good at printf debugging. I'm good at doing those things. So I was like, here, I'll just figure this out. Here, I will do this. So I had to rewrite how we do the data structure on the front end for the TV from what is called a Lolomo, list of movies, into Loloromo, which is a list of recommendation objects for a movie. Why would we need to do that? Think about this. You have two lists. One has Live Free, Die Hard, Bruce Willis, because you love Bruce Willis. The other one has Live Free, Die Hard, because you want tough men doing tough jobs. Well, during those days, we'd only have one way we could show evidence why you wanted it. So we couldn't say, oh, because you liked this other movie. You'd go to that one and say the same thing. So we had to kind of add one level of indirection where we could decorate the video with the recommendation information.
Okay, so you can abstract away into the space of recommendation versus the space of movies directly.
Yeah, so you can't hang it off the video because obviously then it would be the same for everything that shows that same video. So
that's amazing.
I had to do all this, and I wrote it in Groovy, and I just did it. And people were like, how did you write this in Groovy? And it's just like, well, I read the language reference for a day and then programmed it well. What do you mean? It was a very radical language, shall we say. And so I just simply became the person that knew these things. So they just give me more and more jobs at that. And so that's kind of how I excelled, being the person that was willing to do the thing that no one else was.
Yeah, can you actually speak to the printf debugging? Like you walk into a system, and there's a lot of systems in the world like this. Like Twitter was like this when Elon acquired Twitter, and then rolls in, and there's this old janky code base that's just like a giant mess, and you have to basically do printf debugging. Like, what's the process of going into a code base and figuring out like what the fuck? Well, how does this work? What are the flaws? What are the assumptions? You have to like reverse engineer what all these other engineers did in the past, and the mess across the space of months and years, and you have to figure out how all that works in order to make improvements.
The reason why I've always just been good at printf debugging, because one of my first kind of side quest jobs that I got was writing robots for the government when I was still at school. And so I'd kind of do this contractually for so many hours a week. And my boss, Hunter Lloyd, great professor, by the way, he just said, hey, here's your computer. Here's the robot. Here's how you plug it in. Here's how you run the code. Can you write the flash driver, the Ethernet driver? Can you write the planetary pancake motor? Here's some manuals. I'm missing some. Just figure it out. I'll be back. So that was government work for me. So I was like, okay, I'll figure all these things out. And I figured them all out. And the only way to really get anything out of the machine was to print. And so it's like I had to become really good at printing my way through problems. And so that kind of became this like skill, I guess I adopted, is that I can just kind of printf debug my way through a lot of these problems. Obviously, I'm not a game developer, probably a different world. Probably should use, I think John Carmack was on here and talked how great the debugger is. Different world. Because when I was at Netflix, there's machines that exist somewhere where on AWS, I'm not logged into them. I don't even know how to log into them. I'm not even sure if I have credentials to log into them. They run once somewhere, and I have to figure out what happened and why it's happening. So it's like, I'm going to become, this is what I've trained for. Yeah. I'm a printf debugging champion. So it's just like, I could just run through these things really quickly and figure out why they're happening the way they're happening.
You're a special human. I think that's an incredible skill set to have, to be able to drop in into any code base, to drop into any situation and do printf debugging, meaning like, you're in a dark room and you're feeling around that room to try to figure out what the room is.
Well, I had the code, so it's like I can kind of blueprint what's happening. Like I don't understand the services or anything that's happening, but like you can start guessing pretty quick as to what's going wrong.
Right, but then the print side of that helps you confirm your intuitions, test your intuitions, and build up more and more information. And then you start to accumulate like this bigger picture from that, what the edge cases are that break the system and not. I mean, I think that just that kind of space, like that kind of situation is intimidating for a lot of engineers. Like they break down at that point. I think this really is a powerful thing to be able to come into a code base. That's generally a skill set of like, very few of us start from scratch.
Yeah.
And actually, this is the fundamental problem of web development and in general, where they're like, I don't know what's going on. I'm going to write my own thing from scratch, right? As opposed to like actually doing printf debugging on the space of languages, on the space of problems, because there's a lot of wisdom and solved problems already in this code base. it's a much more important skill set to understand, to learn from the mistakes and the wisdom of the past, of the ancestors that came before, and build on them as opposed to throw it all out and start from scratch. This is something obviously you see a lot with a JavaScript framework that comes out, a new one every single day. So
I have a very great story about that. That this is what like I think has shaped me the most about my perspective of other devs. There's this dev, and he always just wrote things in just what I thought was such a bizarre and weird way. And this had to do with Falcor, so our data fetching library for Netflix. This would run on mobile, so I had to write in Objective-C. It had to run on television, and it had to also run on web. So it ran on everything. And me and one other person were responsible for this thing working. And the request side, where we'd have to dedupe the information that we already have, the requests that were pending, and the new data. So I had to figure all that out based on what someone's requesting, and then just only optimally request the stuff that we don't have. He wrote it in such a goofy way, and I'm thinking, man, this guy is just, what a goofball. So I delete it all, and I start writing, and I'm like, look at how much nicer this is. It's looking
Delete
so
code
good.
programming.
I'm like, ooh, there's that one edge case. Okay, I can see why he wrote it this one way. That's not a big deal, though. The rest of my code's really great. By the end of it, I'm like, I literally almost line for line just reproduced what he already wrote. It's like slightly different towards my style, but I just wrote the same code. And I'm like, I'm an idiot. I am the idiot in this situation because it was already a solved problem. I just didn't take the time to learn what he did. Instead, I relearned what he did by rewriting the entire thing.
I think that's a skill set that is extremely important for people to learn. I see that in myself. That's a constant struggle for myself. When facing a code base, for example, but this applies generally in life, where somebody did a lot of work to do a thing, you should invest a huge amount of time and get really good at figuring out what they did, why they did it, do a lot of printf debugging to understand what they did. It's a much more efficient way to understand a problem deeply than to start from scratch, even though there's a constant temptation to start from scratch, because starting from scratch is fun. You do get the puzzle solving, all that kind of stuff. It's just not going to be the right thing to do. Usually pain is the right thing to do, and it is for most people painful to understand other people's code bases.
I think George Horse has that problem, right? We'll take a look at George Horse. He's decided when he doing the intern at Twitter or what X or whatever it is, he trying to rewrite stuff, didn't work out, right? We'll watch that after this.
I highly recommend starting from scratch if you want to understand a concept. You don't know how an HTTP server works? Create a TCP socket, learn how to parse HTTP. It'll become very easy, and you'll go, this is the reason why whenever I get a request, I have to await the text. I now understand why the text is, for whatever reason, not there. I get it. I now understand it. And so you kind of gain these new perspectives just by simply parsing something out.
All right, back to the wisdom of Reddit. Apparently, there are memes and legends about your programming arc in Netflix. This Falcor system you mentioned. Somebody, I think it was Tej. How do you pronounce his name, by the way?
Tej.
Tej. Okay, Tej.
It's TJ would be his name, but we call him Tej. Or Telescopic Johnson.
Oh, wow. So many names. DDoS, distributed denial of service attacks. You apparently were able to accomplish the simplified version of that, of just DOS. That's a legend. So you basically broke down the system somehow.
Yeah. So
can you tell the story of that?
I'd be glad to. So this Falcor. So there's this Falcor business, right? And I did discover the bug before anybody else, and I did report it to security, and it was so bad. It actually got its own name, Repulsive Grizzly Attack.
Yeah.
And they even give examples of how to do it. Effectively, what it means is that there is a request that targets both memory and CPU and will destroy. There you go. Look at that. How Netflix. The next one down was the article that was actually written.
Yeah.
I don't get mentioned, which is a little bit upsetting considering I was the one that discovered it and told everybody how bad it was. Anyways, and had to write the fix for it, or the first fix. So this is how it works: is that you can do something pretty similar, I believe, with GraphQL as well. It has the same kind of danger. Any of these kind of RPC, request as much or as little of the data as you would like frameworks are vulnerable to this kind of attack. So with Falcor, what you do is you give it an array. This an array is called a path, and that's the path to the data. But sometimes you don't want you don't want to have to write out, I want row 0 or list 0 or row 0, column 0 title. I want, row 0, column 0 description. I want, you don't want to have to write out all that. So instead you could just be like, I want rows 0 through 10, columns 0 through 10, titles and descriptions. So you can write in a very compact, nice little format, and it'll give you all that data. It'll go to the server will fill that all in and give it to you. Oh, dang it. List 3, it only had 3 videos in it. So what happens when I try to re-request the data? Well, I need a way to be able to tell my system that you'd have requested the data and there's nothing there. So this is called like they call this like a boxed value. So it's going to be like type something, value, there's nothing there. We've already requested it and there's nothing there. They call, it's like a sentinel value, if you will, a boxed value. And we have this little special flag we'd pass called materialize, meaning that when you ask for a path, we will make sure we fill it out so we don't accidentally erase anything. And at the very end, we'll say, okay, the request you've made has already been made and there's nothing there. Well, what happens if I request rows 0 through 10,000, columns through 10,000, one more item through 10,000, and then a whole bunch of properties, and then ask it to materialize? Well, I'm about to go create billions of objects in the JVM, and what happens to the machine? It stops running. And then if we try to JSON, even if it could create them all, we then ask it to JSON serialize. It's not going to do it, right? Like it's impossible. And so that was the attack vector, is a simple while loop would have taken down and held down Netflix for a very long time, because one request would kill one machine on AWS. And so that means it would just turn it all off. And this was on the website. This was on TV. This was on mobile. Like this was profound. And here's the worst part. It was in production for years. So we couldn't even roll it back. There was no like, oh crap, let's just roll back to 2 weeks ago and we'll kind of fix forward and figure out. No, it's like we could roll back to 2011. Like that's our option is 2011 and that's it. So we had to figure out a way forward and all that. And so it was like the amount of problems that would have happened if someone would have discovered this is unstatable.
Just to be clear, the infrastructure that's serving the videos would shut down.
Yeah, the UI, like you couldn't perform any actions on the UI. You surprisingly could still stream video, but you would never be able to get to a video to stream because every action you would take would be completely shut down. And so it wasn't a DDoS because you didn't need a bunch of computers to try to overwhelm the system by making a bunch of requests. One request, one machine. If we had 50 machines serving the millions of requests, it'd only take 50 requests to shut down the entire UI.
Isn't it possible to do DOS or DDoS on basically any software system? Like defending against all the, closing all those attack vectors is probably really difficult. If you take any sufficiently complicated software system, there's probably so many ways to overwhelm it.
Yeah, this is why people use Cloudflare. I think DHH said it best, which is like, we have our website and we have a strong bodyguard on the outside. So Cloudflare has a bunch of utilities all built in because, obviously, this is why
The CDN.
everyone hates all these Bluetooth devices that connect to the internet, because they just turn into attack vectors where people use those to DOS or DDoS other sites. And so you don't need something sophisticated. You just need a bunch of requests to come in and you can take down websites. And so that's why these fronts are really good at kind of discovering where these problems are. But DOS is a bit different because it doesn't have to be overwhelming by using resources with a whole bunch of requests. It really just means simply that there's a denial of service attack. One of them could be, there's a regex attack that existed where Cloudflare actually did it to itself and shut itself down, which is there's a regex expansion attack where, given the right kind of regex, if you know someone's running a specific regex, you can actually provide input that is maximally bad, and that thing goes to like super processing. It takes 10 seconds to process a single request. Then you only need to make hundreds of requests and you shut down the whole service. It's not like you need some giant machinery to make 1 trillion requests. You only need just some small amount to completely destroy a service. And so the web is an extremely difficult place to do it correct.
This is super fascinating. I do also wonder how many ultra competent, black hat hackers there are versus sort of the good guys versus the bad guys, how many bad guys there are, and what is the average what is the distribution of skill set on the bad guy side that are constantly trying to attack?
I assume there's probably a huge number of just really simple ones, script kiddies, right? Just people trying to just do things. And then there's a huge amount of like social engineering that just goes in where hacking's done not with a computer, but just by,
Yeah.
one of the classic ones. Kevin Mitnick had this one in his book, which was you'd call up
Social
somebody
engineering.
pretending to be like, Charlene, we're doing some auditing and I think your pin's out of date on file. Is it 2323 still? And they're like,
Right.
no, it's 4747. You're like, oh, thanks, Sharon. Boom, you just hacked them, right? Like the classic. People love correcting bad information.
Yeah.
This is like a standard. So like there's all these ways people hack. And so my assumption is that there are really great white hat hackers. There's really great black hat hackers. But the vulnerability space, the thing is that discovering a vulnerability and you don't let anyone know, the white hat hacker still has to make that same discovery.
Yeah.
And that's where I think the real thing is that black hat hacking in some sense has a fundamentally easier job, or at least a job in which they can take advantage of for much longer periods of time. One's the process of discovering who's breaking the system. The other one's trying to figure out how to break the system. And it seems like most software is held together by toothpicks and glue.
Yeah.
And there is a lot of dangers in every piece.
And also the social engineering aspect. That's a real attack vector. I think that's the attack vector that will do in the long term the most damage in the world. Especially as AI tooling becomes easier and easier to convince people at scale, sort of do that kind of email grandma. I think that's a really serious attack vector, like human psychology and all that. I kind of assume whenever there's a girl that approaches me, it's kind of some kind of social engineering project, some attack vector, some intelligence agency. In fact, I'm pretty sure.
We're back to a beautiful mind, aren't we?
Beautiful mind. Yeah. I have a whiteboard upstairs that I calculate everything, everybody's trajectory and move.
You're not wrong, though, with the attack vector, especially in the day of AI. Like one thing that I don't think a lot of people are talking about as we integrate more and more AI is that prompt injection is like an extremely hard thing to defend against because it's not really clear how you defend against it. If it's just at the end of the day, word calculator, make word come out. If you can figure out the proper word calculator input, it might just break its bounds and start doing something it's not supposed to do. And there's a whole future where there's all these products that are going to be vulnerable to things they never thought about. Like it's one thing where you forget an edge case while you're programming. Now you have to guess what people might be able to think of making something that has access to a system be able to do, right? And you don't have a way to reason about it. Its reasoning came from Reddit and other words that it's read and how to put things together. Like this is it's a massive space that's going to be happening. That's why I'm personally thinking, don't give too many powers yet. Like we don't know the attacks that are about to happen.
Okay. This is the one that George Horst was saying about refactoring Twitter. Something like that. Let's see this. What is this?
So you mentioned rewrite before or refactor before features.
Mm-hmm.
If you were to refactor the Twitter code base, what would that look like? And maybe also comment on how difficult is it to refactor?
The main thing I would do is first of all, identify the pieces and then put tests in between the pieces, right? So there's all these different, Twitter has a microservice architecture. There's all these different microservices. And the thing that I was working on there, look, like, George didn't know any JavaScript. He asked how to fix search, blah, 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 blah. Look, man, like the thing is, like, I just, I'm upset that the way that this whole thing was portrayed, because it wasn't like taken by people, like, honestly, it was taken by people who started out with a bad faith assumption.
Yeah.
And I mean, I can't
And you as a programmer just being transparent out there, actually having like fun, and like this is what programming should be about. It's just like
I love that Elon gave me this opportunity.
Yeah. Like
really, it does. And like, he came on the day I quit, he came on my Twitter Spaces afterward and we had a conversation. Like I respect that so much.
Yeah, and it's also inspiring to just engineers and programmers, and just
Yeah.
it's cool. It should be fun. The people that were hating on it, it's like, oh man,
It was fun. It was fun. It was stressful, but I felt like, I was at like a cool like point in history, and like I hope I was useful. I probably kind of wasn't, but like maybe I
Well,
was.
you
I don't know.
also were one of the people that kind of made a strong case to refactor.
Yeah.
And that's a really interesting thing to raise. Like maybe that is the right, the timing of that is really interesting. If you look at just the development of autopilot, going from Mobileye to just like more, if you look at the history of semi-autonomous driving in Tesla, is more and more like you could say refactoring or starting from scratch, redeveloping from scratch.
It's refactoring all the way down.
And and the question is like, can you do that sooner? Can you maintain product profitability? And like, what's the right time to do it? How do you do it? On any one day, it's like you don't want to pull off the Band-Aid. It's like like everything works. It's just like little fix here and there, but maybe starting from scratch.
This is the main philosophy of TinyGrad. You have never refactored enough. Your code can get smaller. Your code can get simpler. Your ideas can be more elegant.
But would you consider, say you were like running Twitter development teams, engineering teams, would you go as far as like different programming language? Just go that far?
I mean, the first thing that I would do is build tests. The first thing I would do is get a CI to where people can trust to make changes.
So that if you
before
keep
I touched any code, I would actually say, no one touches any code. The first thing we do is we test this code base. I mean, this is classic. This is how you approach a legacy code base. This is like what how to approach a legacy code base book will tell you.
So, and then you hope that there's modules that can live on for a while, and then you add new ones, maybe in a different language or
Before we
design
add
it
new ones, we replace old ones.
Yeah, meaning like replace old ones with something simpler.
We look at this thing that's 100,000 lines and we're like, well, okay, maybe this did even make sense in 2010, but now we can replace this with an open source thing, right?
Yeah.
And, we look at this here's another 50,000 lines. Well, actually, we can replace this with 300 lines of Go.
Mhm.
And you know what? I trust that the Go actually replaces this thing because all the tests still pass. So step one is testing.
Yeah.
And then step two is like the programming language is an afterthought, right? Let a whole lot of people compete. Be like, okay, who wants to rewrite a module, whatever language you want to write it in, just the tests have to pass. And if you figure out how to make the test pass but break the site, we got to go back to step one. Step one is get tests that you trust in order to make changes in the code base.
I wonder how hard it is too, because I'm with you on testing and everything. I have from tests to like asserts to everything, but code is just covered in this because it should be very easy to make rapid changes and know that's not going to break everything. And that's the way to do it. But I wonder how difficult is it to integrate tests into a code base that doesn't have many of them.
So I'll tell you what my plan was at Twitter. It's actually similar to something we use at Comma. So at Comma, we have this thing called process replay.
Mhm.
We have a bunch of routes that'll be run through. So Comma is a microservice architecture too. We have microservices in the driving. Like we have one for the cameras, one for the sensor, one for the planner, one for the model. And we have an API, which the microservices talk to each other with. We use this custom thing called Serial, which uses ZMQ. Twitter uses Thrift. And then it uses this thing called Finagle, which is a Scala
Thrift is the Cassandra stuff.
RPC backend. But this doesn't even really matter. The Thrift and Finagle layer was a great place, I thought, to write tests.
Mhm.
Right, to start building something that looks like process replay. So Twitter had some stuff that looked kind of like this, but it wasn't offline. It was only online. So you could ship like a modified version of it, and then you could redirect some of the traffic to your modified version and diff those two,
Mhm.
but it was all online. Like there was no like CI in the traditional sense. I mean, there was some, but like it was not full coverage.
So you can't run all of Twitter offline to test something.
Well, then this was another problem. You can't run all of Twitter, right?
Period.
Well, Twitter
Any
runs,
one person can't.
Twitter
run it.
runs in 3 data centers, and that's it.
Yeah.
There's no other place you can run Twitter, which is like, George, you don't understand. This is modern software development. No, this is bullshit. Like, why can't it run on my laptop? What do you do? Twitter can run it. Yeah, okay. Well, I'm not saying you're going to download the whole database to your laptop, but I'm saying all the middleware and the front end should run on my laptop, right?
That sounds really compelling.
Yeah.
But can that be achieved by a code base that grows over the years. I mean, the 3 data centers didn't have to be, right? Because they're totally different like designs.
The problem is more like why did the code base have to grow? What new functionality has been added to compensate for the lines of code that are there?
One of the ways to explain it is that the incentive for software developers to move up in the company is to add code, to add, and especially large.
And you know what? The incentive for politicians to move up in the political structure is to add laws.
Yeah.
Same problem.
Yeah. Yeah. If the flip side is to simplify.
I mean, you know what? This is something that I do differently from Elon with Kama about self-driving cars. You know, I hear the new version is going to come out and the new version is not going to be better, but at first, and it's going to require a ton of refactors. I say, okay, take as long as you need. Like, you convince me this architecture is better? Okay, we have to move to it. Even if it's not going to make the product better tomorrow, the top priority is getting the architecture right.
So what do you think about sort of a thing where the product is online? So how, I guess, would you do a refactor? If you ran engineering at Twitter, would you just do a refactor? How long would it take? What would that mean for the running of the actual service?
You know, and I'm not the right person to run Twitter. I'm just not. And that's the problem. Like I don't really know. I don't really know if that's, you know, a common thing that I thought a lot while I was there was whenever I thought something that was different to what Elon thought, I'd have to run something in the back of my head reminding myself that Elon is the richest man in the world. And in general, his ideas are better than mine.
Mm-hmm.
Now, there's a few things I think I do understand and know more about. But like in general, I'm not qualified to run Twitter. No, I was going to say qualified, but like, I don't think I'd be that good at it. I don't think I'd be good at it. I don't think I'd really be good at running an engineering organization at scale. I think I could lead a very good refactor of Twitter, and it would take like 6 months to a year, and the results to show at the end of it would be feature development in general takes 10x less time, 10x less man hours. That's what I think I could actually do. Do I think that it's the right decision for the business? Above my pay grade.
Yeah, but a lot of these kinds of decisions are above everybody's pay grade.
I don't want to be a manager. I don't want to do that. I just like if you really forced me to, yeah, it would make me upset if I had to make those decisions. I don't want to.
Yeah, but a refactor is so compelling. If this is to become something much bigger than what Twitter was, it feels like a refactor has to be coming at some point.
George, you're a junior software engineer. Every junior software engineer wants to come in and refactor the whole code. Okay. Like, that's like your opinion, man.
Yeah, it doesn't, sometimes they're right.
Well, like, whether they're right or not, it's definitely not for that reason, right? It's definitely not a question of engineering prowess. It is a question of maybe what the priorities are for the company. And I did get more intelligent, like, feedback from people, I think, in good faith, like, saying that. From Elon. And like, from Elon, sort of like people were like, well, a stop the world refactor might be great for engineering, but we have a business to run. And hey, above my pay grade.
Okay. I guess that's good